In this module, we will teach you about compliance and resistance, which are best understood in the volume control mode. And in a ventilator, when we talk about compliance, we talk generally about the chest wall and the lung parenchyma, whereas whenever we talk about resistance, it means the resistance offered by the airways. Now, what is compliance? In simple terms, it is the amount of pressure required to produce a certain amount of volume. Let's say in normal breathing, we create a pressure difference of around 5 centimeters of water, which delivers a tidal volume of around 500 ml, which would mean that the compliance of the respiratory system is around 100 ml per centimeters of water. Now, when we are delivering a breath on a ventilator, we know that the air has to overcome the resistance offered by the upper airways, and then it has to overcome the resistance offered by the lungs, which are going to expand, which will require a particular amount of pressure. And we are interested in calculating both the resistance offered by the airways as well as the resistance offered by the lungs. This is calculated in terms of compliance and resistance. Now, if we look at the pattern of flow in a volume control mode, we note that the flow goes in a square wave pattern and the pressure peaks, reaches a particular value and falls to the peak levels. Now, suppose the peak pressure achieved is 25 and the peak that we have set is 10. So the difference between the two is around 15 centimeters of water. Now, this is the pressure required to overcome both the resistance offered by the airways as well as the resistance offered by the lungs. If we want to calculate only the resistance offered by the lungs, there is a way that we deliver the breath, distend the lung, and then keep the lungs in a distended state. When the flow ends, the inspiration ends, but the expiration doesn't start. So there is a static period in which the lungs are distended by a particular amount of volume. The inspiration has ended, the expiration has still not started, and the pressure contained at that point of time only reflects the pressure needed to open the lungs. Now, this pause between inspiration and expiration can be produced by pressing a button which is known as the inspiratory pause, or by setting in certain ventilators something which is called the pause time. So, in a state of the pressure increasing to peak and dropping, here we have the pressure increasing to a level of peak, dropping down, and then there is a constant pressure because there is no flow of air. If we look at in the flow graph, how it happens is the flow reaches a peak, remains constant, drops down, and there is a zone of no flow where the inspiration has come to an end but the expiration has still not started. Now, the pressure which is reflected by this peak pressure is produced both by the resistance offered by the airways as well as the compliance of the lung. Whereas this plateau pressure with a new term which has come is when there is no flow of air, which means we are not considering the resistance offered by the airways at any point. It reflects only the pressure required to distend the lungs. Let us say in this example, how can we pick up the resistance, the compliance in the lung? Suppose we set a PEEP of 10 and we see the pressure building up and we set a tidal volume delivery of, let's say, 500 ml. The peak pressure reached is 25 then the pressure drops, remains stagnant at this no flow zone, which is reflected here in the flow graph, and the pressure calculated here is known as the plateau pressure, and then the pressure falls down to P. If we want to measure the resistance offered by the airways, it will be the difference between the peak and the plateau pressure. So here it will be 25 minus 20 is equal to 5 centimeters of water. Whereas if we want to measure the compliance, the difference between these two is 10. So what we do is, we deduct the PEEP from the plateau pressure, which here is 20, minus the PEEP, which is set at 10. So we require a 10 centimeters of water pressure to produce a volume change of 500 ml, which would give a lung compliance of 50 centimeters, 50 ml per centimeters of water. This is to tell you that in a volume control mode, we can check the resistance offered by the airways by deducting the peak pressure from the plateau pressure. We can calculate the compliance of the lungs by deducting the PEEP from the plateau pressure and then dividing it by the volume delivered. So it gives us two ideas. What is the resistance offered by the airways? If there is a huge amount of difference between the peak and the plateau pressure, it actually means that there is a huge amount of resistance offered by the airways, which can happen in bronchospasm, some kind of bronchoconstriction, or because of secretions in the airways, or because of a block in the ET tube. So it gives us a good idea whether we are dealing with some kind of tube block or airway constriction. And at the same time, the plateau pressure gives an idea about the lung parenchyma, about how stiff, how resistant, how compliant is the lung, and how much pressure is actually required to produce a particular amount of volume. This differential pressure is required to check the peak and the plateau pressure. We know that in a pressure control mode, the pressure remains constant. So we can never calculate the peak and the plateau pressure in a pressure control mode. If we want to do that, then we got to put a pause at the end of the inspiration by pressing the inspiratory pause time or setting a pause time, create a no flow zone, check the peak pressure, check the plateau pressure. The peak minus plateau will give us the airway resistance, the plateau minus PEEP producing the tidal volume will give us the lung compliance. So a volume control mode is one mode in which we can calculate the peak pressures, we can calculate the resistance offered by the airways, we can calculate the plateau pressures, which helps us in calculating the compliance of the lungs, and we should be able to pick up these changes because they will tell us a lot about the condition of the airways and the condition of the lungs.